Welcome to our guided tour of the PICOR Precision Loading System, or PLS, by KMEC. Let's start by reviewing the outside of the tower. The PLS stands approximately 60 to 80 feet tall and consists of a single cylindrical tower centered over the loading path, whether it's rail or road. A two-story structure, generally consisting of two separately fabricated and shipped rooms, sits to one side. Internal to the tower are the primary elements of the PLS, the upper level surge bin and the lower level weigh bin. The surge bin holds material and is continually filled by the in-feed conveyor. The weigh bin receives material directly from the surge bin and measures out a precise amount of product to be dispensed. Typical PLS batches range from 1 to 3 weighing cycles. The slide gates, which open and close to allow product to flow into the weigh bin, are controlled by hydraulic proportional valves. This allows the control system to slowly taper off the flow as the weigh bin approaches its desired level. Ultimately, this is what gives the PLS the capability to measure loads so precisely. During the loading cycle, there are two major stages, freefall fill and flood fill. Freefall fill occurs during the first part of the first load, where no material exists in the container to be filled. The material freefalls directly into the slowly advancing container. Ultimately, as buildup occurs in the container, the material stops falling and instead is simply allowed to sink down through the chute into the container due to the forward motion of the vehicle. Generally, before the first batch has finished loading, the second batch has already been weighed and is allowed to fall on top of the remaining first batch, continuing the loading process into the vehicle. This process repeats if necessary for a third time to complete the loading. Let's take a tour around the PLS. On the ground level, the control structure houses the fluid power unit for the PLS. The fluid power unit is used to operate the hydraulics in the system, which includes the slide gates, the loading chute, and the optional man lift. Also located in the ground level control room is the optional dust suppression system, which mixes a foaming agent in water to spray a light foam mist around the material falling into the surge bin. This is especially useful with potentially flammable materials. Access for the material from one bin to the other is controlled by slide gates. PICOR slide gates are hermetically sealed and controlled by proportional valves for maximum effectiveness. Also, the only wear parts are the polyurethane slide blocks, which are accessible from the outside of the gate and can be replaced without any other mechanical disassembly of the PLS. This is a major maintenance time-saving design feature of the PLS. The second level holds the control room, which consists of the main MCC as well as the operator station. The operator station is the primary control point for the entire system, and optionally can control the incoming conveyor as well. We handle either RFID identification of the vehicle or else a simple manifest. All record keeping of dispensed weight is maintained by the PLS. All the operator has to do is initiate a vehicle fill, and the system does the rest. Optionally, the operator can be given direct control via joystick of the position of the chute for finer control of the process. Let's go up the steps to the first floor of the tower itself, where the weigh bin sits. Here we see the main fluid manifold for the PLS, as well as the test weights for the system. These weights are attached to a hydraulic cylinder, which allows the system to be rapidly calibrated by simply emptying the weigh bin and actuating the test cylinders, thereby putting the weight on the load cells. Finally, the optional man lift entry point is here. The man lift allows operators to access the cars to fix potential problems with the car during the inspection run, or else to retrieve foreign material if needed. Moving up to the second level of the tower, we find the surge bin. Note the air duct that follows the curve of the bin. This plenum allows free exchange of air from the weigh bin to the surge bin, which both helps material transfer in and out of the weigh bin, but also keeps expelling of dust to a minimum. There is a mezzanine crawl space for access to the load cells themselves for maintenance, but generally speaking, none is needed. Also on this level, we find the optional fire pump system in case of flame in the surge bin. This is available either as a powered or fail-safe system depending on the site conditions. Finally, let's climb to the roof of the tower. Just before we reach the top, we find the optional catwalk leading to pressure relief panels. When loading potentially hazardous materials, KMEC can design a series of hatches to open in case of overpressure inside the surge bin. This dramatically reduces the possibility of a material combustion event from damaging the tower. Moving on to the roof of the surge bin, we find a sight glass near the downspout from the conveyor discharge. Removing the material, we can see the nozzles for the dust suppression system aimed down in a ring around the falling material. We've even laid out a cleanup port so excess material from the infeed conveyor can be swept directly into the surge bin for loadout and reclaiming. Our last stop is the top of the tower, where the drive for the infeed conveyor sits and can optionally be controlled by the PLS itself. KMEC can handle any custom geometry of the infeed angle and direction, assuring that your material transfers completely into the surge bin and ultimately to the vehicle. This concludes our tour of the PICOR Precision Loading System by KMEC. We look forward to working with you to improve your plant's loading efficiency, cleanliness, and reliability. Give us a call today to start the process.